Zoetewey. I'm going to be doing a demonstration today of a series of reactions known as the copper cycle. So we're going to start with solid copper, and we're going to end with solid copper. Along the way, we're going to see some fun reactions, some really cool stuff happening. Okay, so here I've got some pieces of copper metal, and I'm just going to add. Now, this is nitric acid. This is 16 molar nitric acid. It is very concentrated, and you need to be very careful with it. I'm going to carefully add a little bit of nitric acid. Set that aside. And now you can see this brown gas. That brown gas in my solution has turned green. So this is the same green that you see on the Statue of Liberty. The Statue of Liberty is made out of copper, but it has oxidized over time, so now it has a green coating on it. Alright, so that reaction went pretty quick. All my copper is gone, and it's all in solution as a green liquid. This time I have 1 molar sodium hydroxide. I'm going to add it to my green solution. I'll set it up here so you can see it pretty well. I'm just going to add a little bit at a time. It's going to first turn from green to kind of a light blue as we go from nitrate ions surrounding the copper, which make it green, to waters surrounding the copper, which makes it more blue. So this is as I'm still neutralizing my acid. But eventually, once all the acid is neutralized, and I had really concentrated acid, so I'm going to have to add quite a lot of my there we go. So since that's much lower in concentration, now we see we have a blue precipitate. This is our copper hydroxide, and that is now precipitated, and it's cloudy. Right. The next thing we're going to do is heat it. I'm going to add a stir bar in here. Get that stirring and heating. Now this will take a few minutes to do, but as it heats, we're going to see that it turns from blue to black. Our hydroxide is decomposing into copper oxide, which is black. So now you can see that it has turned almost all the way black. We'll let that go for maybe 1 or 2 more minutes. And it's now fully changed. So you watch the color change from blue to black. So the black now indicates that we have copper oxide. Now there's still nitrate ions in here. So we're going to have to get rid of those. So we're going to do a step called decanting. To get a good decanting, we're going to take this and spin it down in a centrifuge, and then we'll pour off the top. So we got our mixture in 2 tubes. These are equal in volume. We got a little more of our less precipitated in this one, a little more precipitated in this one. But we're going to spin those down. You can see where it's kind of at right now. But when we spin it down, it's going to push it down to the bottom. So we're going to stick it here in the centrifuge, and this is going to spin around at 10,000 revolutions per minute. So as it does, based on the centripetal force, okay, and we heard it beep. Now we can open the lid. You can see it has stopped spinning. So now that it has safely stopped spinning, we can take the lid off. And now, when we take our tubes out, we'll see dramatically. So I'll turn those around so you can see them. We just got a little bit of the pellet down in the bottom. That is our copper oxide. Okay, we're now going to pour off what we have. So this process is called decanting. I'm going to pour it back into the beaker that I had before. Alright. I've got some concentrated hydrochloric acid. This is not as dangerous as nitric acid, but it is still very concentrated, so I'm going to be very careful with it. It shouldn't take very much to dissolve. Okay, this one dissolved pretty well. You can see almost all of that pellet is gone, but it's turned kind of a yellowish color. This is due to the presence of the chloride ions. So because I have chloride at a high concentration, my chloride is complexing with the copper rather than the water. I'm going to now add some water. Pull this up, you can see now we have a nice green solution. I've transferred my green solution, so you can see it here in the beaker, it's nice and green. And we're going to slowly add ammonium hydroxide. So this is ammonia in solution. But you'll notice that as I drops in here, that it's turning blue. Now it's turned completely dark. Whoops. Not completely. We'll have to keep going. I'll give that a shake, our original. There we go. Look how blue this is. I'm going to hold this up to the light. You can see, if you look at it in the light, it is completely transparent. It's a dark blue, but those ions are in solution. They have not precipitated. So this is the copper-ammonium complex. I've been adding concentrated acid. This is dilute acid. This is 3 molar sulfuric. So we're just going to add a little bit of this to it. Voila. It's now gone back to a greenish blue. And now I'm going to add some more water to it. So this is still kind of greenish because of the chloride ions. We're going to get it nice and blue here. And you can see when it's diluted with water, once I dilute away the chloride ions, it goes to a very pale blue. Okay, this thin ribbon here, this is the metal magnesium. So you can find magnesium in bicycles and other things. You can see as I cut little pieces in here, it starts to bubble. So we not only get bubbles that are going to be hydrogen gas. I'm going to move this back to the fume hood in a second. You can also see the precipitate of copper down at the bottom there. And as that bubble themselves, you can see that the copper falls down to the bottom as red copper metal. The hydrogen gas is going to now be sucked up the fuel hood here. And when this solution becomes clear, we'll know that there's no more copper left. You can really see on the bottom that the copper is really precipitating quite nicely. Okay, we've got our copper, and we've got just a little bit of liquid down at the bottom, so I'm going to add some ethanol. Ethanol dissolves the water but does not dissolve our metal. And then, since this is ethanol water, I'm going to put this in organic waste. I'm going to scrape out what we have onto a watch glass. That's most of it, but that's still got a lot of ethanol on it. There shouldn't be any water left. Now we're going to head back over to the fume hood. And I could wait for it to evaporate, but I think it's a little bit more fun. There we go. Alright, that has now burned itself out, but it's fairly hot, so we'll let that dry, but when that dries, we'll have about as much copper as we started with. And that is the copper cycle. Thank you for watching.